Critic, I think that number looks kind of, oh, I don't know, happy?
Now that's just childish. Numbers can't be happy or sad. They're just numbers.
Of course they can. They can be happy or sad, abundant or deficient, narcissistic or actually perfect, prime and composite, square, triangular, and even something called a palindrome.
Right. So how can a number be happy?
Any number that reduces to 1 when you take the sum of the square of its digits and continue iterating it until it yields 1 is a happy number. Any number that doesn't, isn't. There are really some falling standards in recreational mathematics. So to find out whether or not 94 is happy, we have to take the sum of the square of its digits and keep doing that until we get 1 or until we get a loop. So, to take the sum of the square of its digits, we'll have to square 9 and get 81, and square 4 and get 16. And adding them together, we get 97. And then we do this again. We take square 9, 81, square 7, and get 49. Add them together and get 130. And then we square 1, 3, and 0, add those together to get 10, and then square those and add them together and get 1. Because we got 1 when we took the sum of the square of the digits and kept doing that, it is therefore a happy number.
Well, it's pretty easy to understand composite and prime numbers. A prime number is a natural number greater than 1 that has no divisors other than 1 and itself. Do you know how many even primes there are, Bo?
Two things. One, when did we start talking about prime and composite numbers? And I really don't know off the top of my head.
To answer your first question, we just did. The second one, there's only just one.
But 1 isn't prime. It isn't even even.
No, I meant there's only one even prime number. 2.
Now, is there one even prime number, or are there 2?
Just 2.
Which 2?
You really aren't getting this. The number 2.
And the other one?
Alright, and a number is composite if it is greater than 1 and has a positive divisor other than 1 and itself.
So 1 is neither.
That's right, and it seems pretty happy about it. Get it? Because it's a happy number?
Moving on. Kritik, I want to talk about prime numbers again. Specifically, happy prime numbers and co-prime numbers. Do you know what these numbers have in common?
They start with the number 3.
That's true. Anything else?
No.
They're all happy and they're all prime. Happy primes. The best kind of prime number. Any number that satisfies the conditions for being a happy number, that is, you square each of its digits and add them together and keep iterating this process until you get to 1, and also are prime, that is, the only divisors they have are 1 and themselves. So they're all happy and prime. Now, do you know what these two numbers have in common?
They're right next to each other.
That is true. And also, the only divisor that they share is 1. Neither of them is prime, but they're said to be co-prime because they only share the divisor 1. That is, their greatest common factor, the GCF, is 1. Right, moving on, let's talk about abundant, deficient, and perfect numbers and proper divisors. Proper divisors are all real divisors other than the number itself. So the proper divisors of 8 would be 2, 4, and 1. Now, we use the concept of proper divisors to decide whether a number is abundant, deficient, or perfect. So an abundant number is one in which its proper divisors add up to more than the number itself. 18, for instance, is an abundant number. And this is because when we take all of its proper divisors, 1, 2, 3, 6, and 9, they add up to 21. 21 is greater than 18, so 18 is said to be abundant. However, if we look at 16 and take its proper divisors, 1, 2, 4, and 8, we get 15. Now, since the proper divisors of 16 add up to less than a number, it is deficient. 28 is what is said to be a perfect number. Much better than 18 or 16, because when we take all of its proper divisors, 1, 2, 4, 7, 14, and we add all of those together, we get 28. Now, abundant numbers have their own subsets. An abundant number is either semi-perfect or it's weird. Now, a semi-perfect number is one in which some subset of its proper divisors add up to the number itself. So if we look at 18 again, we can find some subset of those numbers, 3, 6, and 9, that add up to 18, making it semi-perfect. 70, on the other hand, is still abundant. All of its proper divisors add up to 74. However, no subset of those divisors add up to 70. It's the smallest weird number, and it does look pretty weird, doesn't it, Krithik?
Speaking of proper divisors, one more type of number is the amicable number. Now, what is an amicable number? Let's take the numbers 220 and 284. Now, if you take the proper divisors of 220 and add those up all together, you'll get the number 284. And if you do the same for 284, add up all its proper divisors, then you'll get the number 220. Mathematicians say these two numbers are amicable, not because they're in love, maybe they are, but because they end up with the same number when you take the sum of the proper divisors. So those are amicable numbers. Well, let's take this a step further and look at sociable numbers. The number 1264460 is a sociable number.
It's also a really big number, Krithik.
It is. So I'll explain why it's a sociable number. Let's do the same process that we did with the number 220. Let's add up all of its divisors, and that gives us 1547860. Another really big number, as Bo would say. And if you keep repeating that process again and again, you'll eventually end up with the number 1264460, which is the number we started out with up here. So any number that this process can be done to eventually end up with the number that we started with is called a sociable number. Next up is cyclic numbers. A cyclic number is one in which cyclic permutations are successive multiples of that number. Now, what in the world does that mean? Well, let's look at an example. 142857 is a cyclic
big number.
It is. Now, all that aside, let's look at why this is a cyclic number. So if we multiply this number by 2, we end up with the number 285714. Now, if you look carefully, you'll see that the same numbers are used to form both numbers. 142857 can be found here as well. 142857. Not only that, they're in the same order, just kind of shifted around a bit. Now, if you multiply this number, the first number, by 3, that gives you the number 428571. Again, it has the same numbers as the original. Keep repeating this process and you'll end up with the same pattern. Multiplying by 4 gives 571428, and I'll let you calculate out the rest. What's interesting is, when you get down to times 7, you end up with the number 999999. So where do these numbers come from? Well, they come from repeating decimals. For instance, the fraction 1 over 7. If you use a calculator and calculate that out, it'll give you the number 0.142857 and all of that repeating. Similarly, if you calculate the number 2 over 7, you'll get 0.285714 all repeating. And do the same all the way to 7 over 7, and you'll get 0.99999 repeating, which is about 1.
Alright, Kritik, we've talked about how numbers can be happy, but what happens if they are vulgar? Vulgar numbers are irrational. It's just another way of saying irrational number. So, the square root of 2, e, pi, are all vulgar, nasty numbers. There are also things called transcendental numbers. That is a non-algebraic number, one that is not a root of a non-zero polynomial expression with real coefficients. So, that means something like any expression that takes this form and isn't zero is a non-zero polynomial expression. And any number that is not a root of any non-zero polynomial expression is said to be transcendental. For instance, the numbers pi and e are both transcendental numbers, or 2 to the root 2 is a transcendental number. Now I know what you might be thinking. Pi and e were vulgar numbers, weren't they? And the fact is, they are both vulgar and transcendental. Pi and e. Now the final type of number we have to talk about actually has a huge subset of different kinds of numbers within it. We're talking about figurates. Now figurates is something that would be a great thing to write a mathematical investigation on. Figurates are numbers that can be represented by a regular geometric arrangement of equally spaced points, which is a fancy way of saying they make a regular shape. So the number 3, represented by an equilateral triangle, is a figurate. The number 4, making a poorly drawn square, is a figurate. 5, pentagon, and so on. But that's not where it stops. There are centered pentagonal figurates. There are cubic figurates, octahedral figurates, and so on. So many types of figurates that you should go and write a mathematical investigation and make a video on.
So that's all we know about numbers. Do you have anything else to say, Bo?
I think they should just take all the mostly useless information we've given them and do something useful with it.
I think so too. And that is some beautiful artwork, Bo.
Oh, thank you.
And that's all we have. Have a nice time.